So we'll start on number 80 on multiple choice. So we left off at 79, but you don't know how to do 79 yet, but you will later this week. We're going to talk about that. Alright, so number 80 says the table gives selected values of a function f. The function is twice differentiable with its second derivative being greater than 0. That's going to be important here in a second. So, which of the following could be the value of the derivative of f at 3? So, normally when we have a table, the way that we calculate the derivative is we use two of the points from the table to find the slope between those points. So, since I'm looking for the derivative at 3, I could either use the first 2 points in the table to estimate the slope, or I could do the last points in the table to estimate the slope. Each of them will just be an estimate, and this is going to help us determine what kinds of estimates they are. Are they underestimates? Are they overestimates? So this is going to kind of help us with that. So if you do the slope between the first 2 points in the table, you would do y2 minus y1 over x2 minus x1. You get 1.2 over 2, which is 0.6. That's the derivative at 3. Another estimate would be to do the last 2 points in the table. So to do 5.4 minus 3.6 over 5 minus 3, which gives you 1.8 over 2. Says if any slopes should be increasing, right? Because the second derivative is the rate of change of the first derivative. This means that the rate of change of the slope is positive. It means that the slope should be increasing. So if the slope between the first 2 points was 0.6 and between the last 2 points was 0.9, right, it should be some number between those two. It should be more than 0.6, right, because the slope at 3 means what's the slope when we are actually at the point 3. We're estimating the slope between 2 points instead of at points. So for me to find the slope of 0.9, it should be less than that at 3. So it should be something between these two. Right? When you use the slope formula, you're estimating the slope. The derivative is the actual slope at a single point, not between 2 points. And so this means that actual, so I only went between 0.6 and 0.9. It's 0.7. That's a B. That was kind of tricky. Alright, 81. At time t equals 0 years, a forest preserve has a population of 1,500 deer. So t equals 0, there's 1,500 deer. If the rate of growth of the population is modeled by this rate equation, deer per year, what's the population at time t equals 3? So we know the population starts off at 1,500 deer. And then to figure out how much the population changes, we're going to take the rate of change of the population and we're going to integrate it. If you want to know the total amount of change, you integrate the rate of change. So if we want to know how much the population changed altogether, we integrate the rate of change of the population. So we're going to integrate 0 to 3. 0 because that's the time where we the population, and 3 because that's the time when we want the population. So we would just type this in the calculator. Let's see. Alright, so we're going to do 1,500 plus, and you can either do menu 4-2, or you can go to the template menu, and it's the second template in the very bottom row. Either way, 0 to 3. 2,000. E, make sure you use the E to the X button. It's right next to the number 1, like right down from the number 1. Make sure you do that and not the letter E. So E to the 0.23t. So 10,141. Choice B. So integrate a rate to get a total. We can figure out how many total deer get added to the population by integrating the rate of change of a population. Yeah. Unless for some reason, I guess if it said, you know, the rate of decay or something like that, then you'd want to subtract. Alright, let's see. Alright, so pay attention on 82. This is the graph of the derivative of f, which means that the y values on this graph are the slopes of our function. Alright, so the figure above shows the graph of the derivative, f prime, the derivative of function f from negative 6 to 8, of the limit which best describes the graph of f on the same interval. So remember, anywhere that your derivative, I guess on here we should also say slopes on this graph equal concavity of our function.
Attention, attention, students. Ashlyn Newton, your ride is waiting out front for you. Ashlyn Newton, please report to the front of the building. Your ride is waiting for you.
So anywhere that the y values change from positive to negative, you'll have a relative maximum on your function, and anywhere it changes negative to positive, you'll have a relative minimum. And anywhere that your slopes change signs, it doesn't really matter which way, you'll have a point of inflection. Right? Because remember, what tells us where we have a relative max or relative min is where the derivative changes signs. So when you're looking at the graph of the derivative, you're looking for where the y values change signs. Positive to negative is a maximum, negative to positive is a minimum. And then your concavity determines your points of inflection. That's the second derivative, which would be the first derivative of the derivative, right? So it would be the slopes of the derivative. So everything's off 1. When you have the graph of the function, slopes aren't slopes, y values aren't y values. They're off 1. Right? The y values are slopes. The slopes are concavity. So this graph, where it goes from positive to negative, where the y's go from positive to negative, would have a relative maximum. And then where they go from negative to positive, they'd have a relative minimum. And anywhere the slope changes signs, so that'd be here, here, and here. Right? It changes from negative slope to positive slope to negative slope to positive slope. You would have points of inflection. So this should have 1 relative minimum, 1 relative maximum, and 3 points of inflection. VA. That's fairly common, so I mean it's worth it to memorize relationships. When you have the graph of the derivative, y values on the graph of the derivative are slopes of your function. So you would look at the y values if you're answering questions about increasing, decreasing, max, min. And then the slopes on your derivative graph tell you the concavity of your function. So you would look at the slopes to tell you about concave up, concave down, and points of inflection. Alright, number 83. Let f and g be continuous functions, and then they tell you 2 things about f, 1 thing about g. And then they ask you what's the value of the integral from 0 to 3 of 1/2 f of x minus 3g of x dx. First off, you can split these up, and the constants can go to the front. So this is really the same as 1/2 the integral from 0 to 3 of f of x minus 3 the integral from 0 to 3 of g of x. So I can do f and g separately, right? Since they're subtracted, we have a property of integrals that says their sum or a difference. You can just integrate each part of the sum or difference. So we can integrate the f and g separately. And then the constant rule says if you have a constant in front of your function, you just integrate and multiply by that constant. So really what we need to do is figure out what's the integral from 0 to 3 for f of x, and what's the integral from 0 to 3 for g of x. Because then we can figure out the rest of this. So for f, they tell you 0 to 6 and 3 to 6. So they tell you from 0 to 6, the integral is 9. And from 3 to 6, the integral is 5. So the whole thing is 9, from 0 to 6. The part from just 3 to 6 is 5. So that means from 0 to 3 would be 4. So this would be 1/2 times 4. Minus 3 times. And then they tell you that from 3 to 0 is negative 7. So if we switch the numbers, we switch the bounds, instead of 3 to 0, we go 0 to 3, it's going to make that positive 7. It's going to switch the sign. So we'd have 2 minus 21, which is negative 19. This is B. Huh? Yeah. Like you second guess for a second. Yeah. All right. 84. The regions A, B, and C in the figure above are bounded by the graph of the function f in the x-axis. The area of region A is 14. The area of region B is 16. The area of region C is 50. What's the average value of f on the interval 0 to 8? So we talked about, I think the last session, average value, right? You're going to take the width of your interval, so from 0 to 8, and we're going to do 1/8. Whatever the width of your interval is, that's what you're going to go on the bottom. Because remember, to find an average, you find the total and then divide by how much there was. So the interval 0 to 8 tells us that our width of our interval was 8. So we're going to find the total and then multiply by 1 over the width of the interval, 1/8. Right? So we would do 1/8 of 14 minus 16 plus 50. Should be 1/8 of 48. Should be 6. If our interval had been from 2 to 8, we would have done 1/6, or from 5 to 8, we would have done 1/3. So whatever the width of your interval is, when you're doing average value, it's 1 over the width of the interval times the total. And the total we get by integrating, or in this case, adding up the areas. Alright, 85. We just got through talking about motion. This is a motion problem. The particle moves along the x-axis, so the velocity is given by what's the total distance traveled from 0 to 2. So remember, for total distance traveled, you integrate the absolute value of velocity. Alright, so we're just going to put this in the calculator. So we're going to do the integral from 0 to 2 of the absolute value of t squared minus 1 over t squared plus 1 dt. 0.927. So you just have to remember, to find total distance traveled, you integrate the absolute value of velocity. No, it's pretty straightforward. Any questions? Alright, 86. Line L is tangent to the graph of y equals e to the x at the point k, comma, e to the x. What is the positive value of k for which the y-intercept of L is 1/2? Alright, so when we write the equation for a tangent line, we typically use point slope, which means that we need to know the point and the slope. So we have a point, x1, y1, and we can find the slope by taking a derivative and plugging in our ordered pair, right? So the derivative of y equals e to the x is just e to the x. Remember, the derivative of e to the power or whatever is just that power of e times the derivative of the exponent. So it would be e to the x